Welcome to the lecture number 9 of Theory of Computation. So in this lecture we will go through what is regular expression, the operators in regular expression and the precedence of operators in regular expression. Then we will go through some examples. Okay. So why regular expression is useful? So let me define you a thing. Regular expression can be used to represent infinite number of strings through a finite number of symbols. For example, if I want to represent all the zeros, so all the zeros means here simply I can write 0, 0 star. So it means what? It is a concatenation of 0 then followed by 0 star. So 0 star is nothing but it represents epsilon. It represents the strings a single 0. It represents two zeros. So this one I have already told you in lecture number 2. Okay. So if you have forgotten, then I request you to go through lecture number 2. So now if I want to represent all the binary strings that is divisible by 2. Divisible by 2 means any combination of zeros and ones, 0 plus 1 star, which is terminated with 0. So here you see if I want to check whether 100 is divisible by 2 or not. So here you see it is divisible by 2, 100 means 4. Now you see this is represented by this regular expression also. So in this regular expression it represents which strings? So it represents 0. So when 0 plus 1 star is epsilon, it represents only 0. When 0 plus 1 star represents 1, so it will represent 1 0. So it will represent 1 0. When 0 plus 1 star represents 1 0, so it will represent 1 0 0. 1 0 0. Similarly 1 1 0. So all the binary strings that are divisible by 2 can be represented by this regular expression. So now you see, I have already told you in the first class while giving the motivation for theory of computation that in a programming language, in order to represent all the valid identifiers, so valid identifiers means, for example, let me take C language. So in it all the valid identifiers length is 31. Okay, so length is 31. In those 31 places or in those 31 places, you what you can put at the first place you can put A to Z, small a to Z, capital A to Z, and underscore. And after that, because every identifier starts with an alphabetic character or underscore. Then it consists of alphabetic characters A to Z, capital A to Z, underscore, and 0 to 9. So in order to represent all the valid identifiers, it is pretty difficult to represent. But regular expression provides you a way. So in regular expression, what you can do? 0 to 9, or first we can do 0 to 9. First let's go through A to Z, capital A to Z, then underscore. So it will be the first character of an identifier, then followed by it will be A to Z, capital A to Z, 0 to 9, and underscore, and its power is 31. So you see, so here out of all the characters we will collect one character, and out of all these characters we can represent it to the power 31. Okay, means 31 characters can be taken out of it. So it represents all the valid identifiers in a C programming language. So this is the power of regular expression. If you want to search a string from a document, then there also you are using regular expression for string matching. Okay, so what exactly a regular expression is? So regular expression are used for representing certain set of strings in an algebraic fashion. It means what? If you want to represent the string, suppose you want to represent a language epsilon 0 0 0 0 0 0, like any number of zeros, then you can use regular expression to represent it algebraically. So if you will write simply 0 star, it represents all the strings. Okay. So regular expression is used to represent certain set of strings in an algebraic fashion. Okay. So algebra, I hope all of you have heard the term algebra. In algebra also there are certain operators, and those operators are applied with certain precedences. Okay. So similar to that, here also in regular expression there are some operators. So what are the operators in regular expression? So this is an operator. So I have divided the operators into one basis, another one is recursive stage. So basis means these are the primitive regular expressions. So phi is a regular expression. So what is the language accepted by phi? It is nothing but L of phi equal to phi. Epsilon is a regular expression. So what is the language accepted by epsilon? It's epsilon. Okay. So A is an input alphabet. So suppose A is a symbol of the input alphabet. Then A is also a regular expression. L of A is nothing but it represents a string A. Right? So in the recursive step, so if R1 is a regular expression and R2 is a regular expression, then R1 plus R2 is also a regular expression. So now here you see the language accepted by R1 plus R2 is nothing but the union of languages accepted by R1 union language accepted by R2. So all the strings that is either present in R1 or present in R2 or in both will be present in L of R1 plus R2. L represents the language, right? So if R1 and R2 are two regular expressions, then R1 concatenation R2 is again a regular expression. So here you see L of R1 concatenation R2 will give you what? It will give you the concatenation of two languages R1 followed by language of R2. So the concatenation of two languages also I have already told you in lecture number 2 of theory of computation. So if R1 is a regular expression, then R1 star is a regular expression. So what is the language accepted by R1 star? It is nothing but it is R1 star. The language accepted by R1 star. R1 star means all the symbols of R1 including epsilon, okay, which is a zero length string. So if R1 is a regular expression, then bracket R1 is again a regular expression. So what is the language accepted by bracket R1? It is nothing but the language similar to accepted by R1, right? So now let me go through the precedence of these operators. So first precedence, the star operator is having the highest precedence. Then concatenation operator is having the second highest precedence. And then the union or plus operator is having the third highest precedence. It means what? So you see precedence means it determines the order of evaluation. If I will write 2 plus 3, 5, 3 multiplied by 5. So here you see which one will be performed first. Multiplication operator is having higher precedence than plus operator. So I will first multiply 3 into 5, 15 plus 2. So I will get 17. Similarly, in regular expression, if I will write a regular expression 0 plus 1 star B. So here you see there is a star operator, there is a plus operator, and here there is a concatenation operator. So which operation we will perform first based on the precedence. So here you see that star operation is having the highest precedence. So first we will perform 1 star. So 1 star means epsilon 1, 1, 1, 1, 1, 1, 3 ones, 4 ones, like that it will go. So it will represent a string. Then it will perform the concatenation with B, right? Then whatever you will get over here, then it will make a union with 0. Okay, so this is how the operators of regular expression are precedented. Okay, so the star operator is having the highest precedence, the concatenation operator second highest, and the union or plus operator is having the third precedence. So now let us go through some examples in order to understand these things very carefully. So now I want to define regular expression that accepts the following strings over the input alphabet AB. So here the input alphabet is A, B. So which language I want to represent? L of R equal to A. So if I want to represent only a single terminal, then what is R? R equals to A. So it represents a language which contains a single string, that is A. Now I want to write the regular expression for the language which contains two strings A, B. So what will be the regular expression? The regular expression will be R equal to either A or means plus operator plus AB. So this is the regular expression. So in this regular expression you see there are two operators. One is concatenation operator, another one is plus or union operator. So here the first concatenation operator is having higher precedence than union operator. So first AB will be concatenated, then whatever we will get, that will be united with A, right? So now L of R equal to all strings over A. All strings over A means the regular expression will be A star. Okay, so A star is nothing but it will represent epsilon single A, 2A's, 3A's, similarly all the A's. Now all strings over A and B. So what should be the regular expression? R equal to, so A plus B, it means either A or B, over that we will put a star. Okay, so star operation I have already told you. If I will write input alphabet to the power star, then it represents input alphabet to the power 0 plus, or union input alphabet to the power 1 plus input alphabet to the power 2 plus dot dot dot. Okay, so here it will accept, so 0 length string is epsilon, here it will represent one length string, here it will represent two length string, similarly it can represent n length string. So I hope you have remembered these things. We have already studied these things in lecture number 2. Now L of R, what is the language? All strings over AB but terminated by BB. So what we will write? What should be the regular expression? The regular expression will be A plus B star, means all the strings over AB, but it should be terminated with two B's. So finally it will be concatenated with two B's. Okay, so here it represents all the strings over AB terminated with two B's. Now let me ask you one question. All the strings of A and B which is started and terminated with A. Now can you tell me, can anyone tell me what should be the regular expression for this question? I want your answers. All strings over AB which is started and terminated with A. Similar to this one, you can answer. So here you can see A plus B star, any combination of AB, but it should be started with A and it should be terminated with A. But now you see here, if I will put instead of A plus B star, if I will put epsilon, then I am getting 2A. So there is absolutely no problem. 2A is a string which is started with A and terminated with A. But there is another string which is started with A and terminated with A. What is that? A. So if you will simply represent a single A, then it also started with A and terminated with A. So what should be the regular expression for this one? So the regular expression for this one equal to R equal to A concatenated with A plus B star terminated with A, or it is a single A. Now let me go through some other examples. Okay, write regular expression each of the following set of binary strings. So binary strings means what is the input alphabet? The input alphabet will be 0 and 1. Okay, so now all binary strings means, can you tell me, can anybody tell me what should be the regular expression for this one? All binary strings. I want answers from your side. All binary strings means what should be the language? So it should be epsilon, it should be 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, dot dot dot. So your regular expression should represent all these strings. So it's nothing but 0 plus 1 star. So 0 plus 1 star means 0 plus 1 power 0. Power 0 means it will represent epsilon. Okay. Union 0 plus 1 power 1. Power 1 means either one length string, either 0 or 1. So it will represent 0 and 1. Union 0 plus 1 to the power 2. To the power 2 means what? To the power 2 means 0 plus 1 to the power 2. It is nothing but 0 plus 1 multiplied with 0 plus 1. So what you will get? Either you will get 0 0, here you will get either 0 0 or 0 1 or 1 0 or 1 1. Similarly, union 0 plus 1 to the power 3. So here what you will get? 0, 3 length strings. So similarly dot 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 all the strings you will get. So the regular expression 0 plus 1 star represents all the binary strings of all length, means 0 length, 1 length up to n length. Now the second question is all binary strings except the empty string. It means what? It is similar to this, but here it should not accept this epsilon. So what you will write? So 0 plus 1, 0 plus 1 star concatenated with 0 plus 1. So now you see this one will represent what? This one will represent epsilon 0, 1, 0, 0, 0, 1, 1, 0, 1, 1 dot dot dot. So you have concatenated with what? Sir, class also. What? So here you have concatenated with what? Here you have concatenated with 0 plus 1. Right? So what you will get? 0 into epsilon you will get 0, 1 into epsilon you will get 1, 0 into 0 you will get 0 0, 0 into 1 you will get 0 1, 1 in 1 concatenated 0 you will get 1 0. So you see you will get all the strings but excluding the epsilon string. So here 0 plus 1 concatenated with 0 plus 1 star will accept all the binary strings except the empty string. Now we want to represent all binary strings started with 1 1 and terminated with 0 0. Can anyone answer this question? All binary strings means 0 plus 1 star that had started with 1 1. So I have concatenated with 1 1 and terminated with 0 0. So this is the regular expression for this one. Contains at least two ones. At least two ones means that. So what should be the regular expression for this one? 1 1. So at least two, minimum two. Okay. So before that, any number of zeros and ones, 0 plus 1 star. In between that, any number of 0 and 1. In after that, any number of 0 and 1. Right? So this is the regular expression for representing all the binary strings, that is exactly at least two ones. Okay. So now what we have? Contains exactly two zeros. So two zeros means the regular expression should be 0 0. So it contains exactly two zeros. So before it any number of ones means 1 star. After it any number of ones 1 star. After it any number of ones 1 star. So here you see it represents all the binary strings, that is exactly two zeros. But the number of ones is not restricted. It may be 0, maybe 1, maybe 2, maybe 3, or maybe anything. Okay. Next. So contains at least three consecutive ones. So three consecutive ones means 1 1 1. At least it should be there. So before it there can be any number of zeros and ones, 0 plus 1 star, and after it there can be any number of zeros and ones, 0 plus 1 star. So I hope all of you have understood this. Next, write regular expression of for each of the following set of binary strings. Contains a substring 110. So the regular expression should be r equal to 110. Before it any number of zeros and ones. After it any number of zeros and ones. Okay. Has at least 3 bits and the third bit is 0. Okay. So here what is the question? It should have at least 3 bits. So at least 3 bits means either 0 plus 1, but the third bit is 0. So first bit may be 0 or 1, second bit may be 0 or 1, but the third bit is 0. So after that any number of zeros and ones, because it has at least. Okay. So after that any number of zeros and ones. So as you will do some problems by yourself, in that process you will learn how to devise regular expressions. Okay. So here I am just giving you some examples so that you can kick start with. Okay. So starts and ends with the same bit. It means what? Started with 0, ended with 0, or started with 1 and terminated with 1. So what should be the regular expression for this one? So for 0 you will write, so 0 means started with 0 and ended with 0. Then 0, 0 plus 1 star 0. So it represents all the strings, binary strings that have started with 0 and ended with 0. So it will accept this one. Next it will accept all the binary strings that have started with 1 and terminated with 1. So this is 1 which has started with 1 and terminated 1, and this one is 1, 0 plus 1 star 1. So started with 1, ended with 1. In between that you may have any number of zeros and 1. So now you see this is a regular expression, this is a regular expression. I have made union between these two, means it will accept all the strings that is accepted by this regular expression and accepted by this regular expression. Now number of zeros is a multiple of 3. So there is no constraint on ones, but the number of zeros should be a multiple of 3. So what we will do? So there should be 3 zeros. Okay. Now ones may be at any place. So 1 star, 1 star, 1 star, 1 star. So similarly, now it's any number. It's any number means the whole bit star. So that it will represent all the binary strings that has multiple zeros, that has zeros which is multiple of 3. So if this star will be epsilon, then you will have zero number of zeros, so it is divisible by 3. Okay, so if this star is 1, I will contain one length strings for this one, so you will have exactly 3 zeros which is a multiple of 3. Then if it is 2, you will have 6 number of zeros. If it is 3, you will have 9 number of zeros. Similarly it will go on. All bit strings with even length. Even length means what? So 0 plus 1, so this is 1, 0 plus 1, this is 1 bit. So 2 bits star means it is a multiple of 2. Similar to here, multiple of 3 zeros, here it is a multiple of 2. So out of this, either if you will select 0, here if you will select 1, so 0 1 star it will do. So it may be any combination. So from here either 0 1, from here either 0 1, then it star. So it should be either 0, that is epsilon, or 2 number of zeros or ones, or 4 number of zeros or ones, or 6 number of zeros or ones, or 8 number of zeros or ones. So it represents even length. Okay, so now all bit strings with odd length. Odd length means what? Even plus 1. So I will write the even over here, 0 plus 1, 0 plus 1 whole star. So it represents even length string, and before that I will keep 1, either 0 or 1, so that if I will concatenate one length string with a even length string, I will always get an odd length string. So now I hope all of you have a glimpse of regular expression and how to write regular expression. So thank you. I hope all of you have understood it.